Alright everybody, welcome back. In this video we're going to talk about information from section 2 of unit 4 of AP Calculus, straight line motion, connecting position, velocity, and acceleration. And my little introduction here, one of the most common applications you're going to see on your AP test for derivatives and for integrals later is the concept of particle motion or straight line motion or rectilinear motion. You might hear it referred to as any of those things. What we're going to do in this lesson is we're going to look at the basic relationships between some of the aspects of particle motion and how we can use what we've learned about derivatives to handle, applied problems in this context. So our first term here, position, that should be something that you're relatively familiar with. What is your position? Where are you? Most frequently in this course, you'll see position written as S of t. We might also see it written as X of t or Y of t in order to talk about the direction that the motion's happening. Like S of t is kind of a generic all-purpose catch-all position function notation, whereas X of t usually describes when something is moving along the x-axis, or in an x direction, and Y of t talks about when things are moving along the y-axis or in like a y direction. Position is always measured in units of length, like feet, meters, inches, miles, etc., etc. Any measurement of length could be a unit for a position function. Next on the docket, velocity, which we will almost always write as the function v of t. Velocity is the derivative of position. Okay, so if a position function is s of t, then the velocity is s prime of t. Velocity is measured in units of length per unit of time, meters per second, miles per hour, feet per minute. Any combination of a length unit divided by a time unit would be a good unit for a velocity measurement. And then acceleration. Acceleration is almost always written as the function a of t. It is the derivative of velocity. So if position is s of t and velocity is v of t, then a of t is equal to, it's the first derivative of velocity or the second derivative of position. It's measured in units of velocity per unit of time, so like meters per second or miles per hour per minute. Depending on which one of these we particularly have, there might be some kind of shorthand. Certainly I've seen and used meters per second squared in this context, although I couldn't use an abbreviated unit like that in this context, when I've got miles per hour per minute or something like that. I actually, as I've done this longer and longer and gotten older and older, I tend to prefer writing an acceleration unit like this instead of abbreviating it as meters per second squared. I think this is a more descriptive way to write the unit that does a better job of describing what it really means. But, alright, let's go ahead and look at a couple of examples. Example 1. A particle's position along the x-axis in meters is given by x of t equals 8 sine of the quantity pi over 6t plus 4, where 0 is less than or equal to t is less than or equal to 10, where t is measured in seconds. And we're asked what's the particle's velocity at time 7. Okay, so we're trying to find velocity. We know position. In order to get the velocity function, all we need to do is take the position function that we have and take the derivative of it. So velocity, the velocity function is going to be the derivative of the position function. And now I'm going to take the derivative of the function that I have here. I've got a constant multiple 8, and then I'm going to need to use the chain rule on the sine of the quantity pi over 6t. So derivative of the outside, leaving the inside the same, times the derivative of the inside. The derivative of pi over 6 times t is just pi over 6. And then I add to that the derivative of 4. Since 4 is just a constant, the derivative of that is 0. And I'm going to go ahead and simplify this a little bit. This is equal to 4/3 pi times the cosine of pi over 6 times t. Okay, now, in order to find the velocity at time 7, well, all I need to do is substitute 7 into my velocity function in place of time. So this turns into 4/3 pi times the cosine of, and I put 7 in here for time, and that makes this the cosine of 7 pi over 6. And the cosine of 7 pi over 6, let's see, where's 7 pi over 6? Going around the unit circle here in my head, that's negative square root of 3 over 2. So we've got 4/3 pi times negative square root of 3 over 2. And we simplify that, and it turns into negative 2 pi root 3 over 3. And I need units here. And my units, since the position is measured in meters and the time is measured in seconds, velocity is measured in units of length per unit of time. So this is going to be meters per second. And if you're one of those people who likes decimals and you punch this into your calculator, either of these two answers, because of the rounding and truncation, would be acceptable answers for this particular question. All right, part B of this example. What is the particle's acceleration at time t equals 5? Okay, so first I need to get the acceleration function. Acceleration is the derivative of velocity. So all I'm going to do is I'm going to take my velocity function, and I'm going to use the simplified form from right up here, and I'm going to go ahead and take the derivative of that in order to get my acceleration function. I've got the constant multiple, 4/3 pi, and then I'm going to need to apply the chain rule to take the derivative of cosine of pi over 6 times t. That's going to be derivative of the outside, leaving the inside the same, times the derivative of the inside, which is pi over 6. And so when I simplify all of this, this ends up becoming negative 2 over 9 pi squared. That's a combination of all my constants together, this one, and the negative sign. And then it's just sine of pi over 6t. Okay. And now in order to find the acceleration at time 5, I'm going to go ahead and substitute 5 in here. So this becomes negative 2 over 9 pi squared times the sine of 5 pi over 6. And let's see, 5 pi over 6, the sine of 5 pi over 6, thinking my way around the unit circle, that's just 1/2. And so this is negative 2/9 pi squared times 1/2. And so this ends up becoming the opposite of pi squared over 9. My units, unit of velocity, which was meters per second, per unit of time, so it's meters per second per second. And for those of you who like decimals, acceptable answer is negative 1.096 or negative 1.097, depending on if you round or truncate. Okay, so there's the basic relationship between position, velocity, and acceleration. And a couple of examples of how we can find velocity and acceleration. And I think, you know what, we're going to call it quits for this video there, and we'll come back next time with a second video with a whole lot more information about straight line motion. So we'll see you next time. Enjoy the rest of your day and come back for a whole lot more yet to come on these relationships. All right. Bye-bye.